Alright, let's do the force diagram for this bad boy. We have the weight of the can. I have some tension going up at a 40-degree angle. I also have a normal force normal. And I have some friction, force of friction, static, off to the side there. So there's a lot going on. We should probably say, whoops, I never labeled my tension, my force tension there, which means I have a tension times the sine of 40 over here, and I have tension times the cosine of 40 over there, and then I can just kind of ignore that hypotenuse tension. So I have 1, 2, 3, 4, 5 forces that I have to deal with. Let's do some of the forces. I'll come over here, try to save some room. Some of the forces in the x direction. It's not moving. We want to find the point at which it will start to move, so we'll do sum of the forces equals 0. And what are those forces? So in the x direction, I have force friction static, which is negative, and I have a tension times cosine of 40 degrees equals 0. Nothing really can help me out there. I could turn force friction static into negative mu times force normal plus tension. My force normal is not my weight this time because I've got that crazy other vertical force of the tension. So that's about all I can do with that. Let's go to some of the forces in the y direction. They also equal 0. I have a force normal. I have a plus. Did I just use the wrong colors here? I did, didn't I? My bad. Plus tension sine of 40. Flip-flop my colors. And I also have a negative weight, force gravity, and all those equal 0. The only number I have is the mu, which is a 0.60. That's all I have. So I'm going to have to do some substitution here. I'm going to go back to my x, and I'm going to say t cosine of 40 degrees equals mu force normal. And then I have to, let's get this mu to the other side, and that's going to be gone. So everywhere I see a force normal, I'm going to substitute it out there. I'm going to come writing over here. My new force normal is t cosine of 40 degrees over mu plus t sine of 40 degrees equals force gravity. Actually, no, let's keep that as negative. Minus force gravity equals 0. Someone's trying to come into the room. Alright, let's get back to this. I'm going to add this Fg to both sides. And I'm going to divide out, whoops, not divide out. I'm going to multiply the mu by both sides, and then I'm going to take a t out of cosine of 40 degrees plus sine of 40 degrees, and all of that is going to equal Fg times mu. How do you get t all by itself? I am going to, whoops, t equals force gravity mu. I kind of lied, we did have another number up here, but force of gravity times mu divided by cosine of 40 degrees plus sine of 40 degrees. And my force of gravity is going to be 3 times, I don't know why I'm going to use 9.8 because I've been doing a lab. 3 times 9.8, and I get 29.4 newtons. and my mu is 0.6, and all of that is over cosine of 40 degrees, 40 degrees, plus sine of 40 degrees, 29, I already had 29.4, multiply that by 0.6, I get, still don't have enough room, multiply it, so I get T equals 17.64 newtons, and then let me do the, just drop my calculator. I get cosine of 40 plus sine of 40 equals 1.41, 17.64 divided by answer equals 12.5 newtons. Woo woo, woo woo.